So now I'm with Alfred H. Knight. I'm with Patrick Mare, who's the global lead for the circular economy. Welcome, Patrick. And Laurance Donnelly, who's both chief geologist and head of the technical department. Welcome, Laurance.
Thank you.
Patrick, I'll start with you. Start by telling us a little bit about Alfred H. Knight.
Thank you, Jill. Alfred H. Knight is a family-owned, independent testing and inspection company with 140 years of experience and covering 5 generations. We cover the metals and mineral supply chain from ores, intermediate materials, refined metals and through to secondaries in the circular economy, which is the focus of us today.
And here we are at the International Electronics Recycling Conference 2025. Can you tell us why you're here?
Well, we've been attending for a few years and it's always been very successful. The audience that is secured at the conference all are interested in the complex materials within the circular economy, and we have the opportunity to talk to customers, potential customers, about the issues that they're seeing with these materials and how we may be able to help them.
And what is the reach of Alfred H. Knight? Is it a global company?
Yes, we've having been in existence for some time, we've been around the world and we're in over 40 countries. The focus for the Circular Economy Division is really in North America, Europe and Asia, and one of our key focuses at the moment is the sampling hub in Holland, where we've really shown that statistically the controls that we can bring to sampling and analysis can drive better understanding of the materials and the commercial value.
And in concrete terms, what is that? What does that mean? What is the approach of the group?
Yeah, so with the complex materials, we understand them technically. We look at the textures, where the metals are, so that we can inform our processes of sampling and analysis, which actually can bring a lot of value to the wider industry. And this is the topic that my colleague Laurance has been presenting on at the conference this year.
Absolutely. So Laurance, yes, over to you. How does your work contribute to the field of electronics recycling?
My work contributes because e-scrap is incredibly complex. It's what we call heterogeneous, and this is because of the variety of electronic components in the samples. And what we've been able to do in Alfred H. Knight is to use existing techniques often applied to mineral exploration or forensic geology in order to understand this heterogeneous nature of e-scrap and their complexities. And these techniques include binocular microscopy, scanning electron microscopy, X-ray fluorescence, and automated mineralogy.
Okay, and how do these findings then inform the development of sampling strategies and the processing of e-scrap?
Well, because of the complexities of e-scrap, you can envisage that just a few grams of e-scrap that we sample has to represent the material from which it came. And this is incredibly complicated due to this heterogeneous nature. So our sampling strategies and the results of our work ensure that the samples we take are unbiased, they're representative of the original mass, and that they align with what we call the theory of sampling.
Okay, and the impact that these optimised strategies could have then on metal extraction and environmental outcomes, how do you see that?
Well, because e-scrap is potentially detrimental to the environment, if, for example, it went to landfill, the result of our work enables what we call the payables, the metals of value, and the penalty components, the metals or the elements that could be detrimental to smelters, refiners or the environment. Our work enables us to understand the textual variability, and therefore it enables us to advise on whether processing by hydrometallurgical, pyrometallurgical or biohydrometallurgical options are most cost effective and most pragmatic.
And the research that you showed to us yesterday for the first time, I believe, how does that align with global trends in electronics recycling and recovery of resources?
E-scrap and in particular PCBs are set to increase in quantity over the next few years, and by 2030, for example, there'll be approximately 75 million tonnes of e-scrap in circulation. Now, what the result of our research has allowed us to do is to ensure that the metals are extracted in a manner that's pragmatic, cost-effective, thereby reducing the amount of e-scrap that can go to landfill.
And how do you think that your results could shape industry standards for the future?
Well, the next step in our research is to collaborate with industry and to ensure that the results of our work are distributed globally and that we can start to develop international standards. So whether we're taking samples and preparing samples in Europe, USA, China, Africa or Latin America, there are agreed standards for industry. This will facilitate traders and producers of e-scrap to ensure that there's a standard approach.
Great. And just finally back to you, Patrick. Are you making interesting contacts at the conference? Is it going well?
It's been a very successful conference. We've had a lot of interesting meetings, and we look forward to attending next year as well.
That's great. Well, we wish you lots of great contacts and good luck with the research, and thank you very much.
Thank you.
Thank you.
Thank you.